All right, we're going to take a few minutes to go through the benchmark unit by unit and see if we can help answer your questions so that you can view this at home and help. As one variable increases, the other increases. That is actually direct. I'm sure if you have your notes from the first unit, you'll see that. As one variable increases, the other decreases. That is a classic definition of inverse. As one goes up, the other goes down. All right. Letter C, the equation works that way too. Y is up when X is down. K is your constant. That is also inverse. All right. And number 4, when Y is up, X is up. So if X gets bigger and bigger, the Y answer is also going to get bigger and bigger. That is how direct works. All right, number 2. Identify which is the direct graph. Letter A is the direct graph. It shows that as you go farther and farther and farther to the right, the answer is getting bigger and bigger and bigger. So as one increases, the other one increases. This one is inverse. Pick any one quadrant. Usually we focus on the top right quadrant. As we get farther and farther and farther, this answer is coming down, coming down, coming down. So it's getting less and less. So as one increases, the other decreases. Direct and inverse. Interest on a loan is varied directly with rate. It varies directly. It means it should change in the same way. So if the rate is in half, then the interest we're going to earn is also halved. Okay? It's a direct relationship. As one goes up, the other goes up, or if one goes down, the other goes down by the same amount. So if it's halved, the other one's halved. Time it takes to do a construction job varies inversely with the number of workers. A boss on a job site triples the number of workers. Okay, let's remember that this is inverse. He's going to triple. So if there's 3 times as many people on the roof of the building and on putting up the floors and all that stuff, 3 times more people would mean that the job should take less and less and less. How much less? Well, proportionally, if you triple the number of workers, multiply them by 3, you should cut the time in by 3. So it's cut by 1/3. Y varies inversely with X. We start with an equation that represents a basic inverse equation. So I'm writing my generic equation. Now I'm going to solve for constant K. Multiplying by X on both sides, constant K is an X number times a Y number. All right. In the middle, I've given you an X number and a Y number that go together. So 3 times 16, 48. Constant I'm looking for is 48. Now I'm going to use that constant in the equation. This is the actual equation that represents all of these relationships for this problem. Find X when Y is 6. Okay. So 6 equals 48 times X. Sorry, my bad. I wrote that wrong. Solved it right, wrote it wrong. Let's go back to this step. My bad. So sorry. Y is equal to 48 over X. And now if I put in X, 6 is equal to 48 divided by X. So X would have to be 8. My X answer is 8. Sorry, I got off track there. Y varies directly. So Y equals 8K times X. To solve for K, I'm going to divide. So to get K, I'm going to take a Y number divided by an X number. Here's a Y and an X number that go together. So Y is -4 when X is 2. So my K number is -2. So the equation I need to use is -2 times the X number. All right? So now I'm going to substitute in right here for X. Y is equal to -2 times -6, which equals +12. All right, number 6 is +12. When the rice is prepared, the amount of rice varies directly. So now I have words. So amount of rice varies directly with the water. And I'm going to put constant K here. Okay. Now I'm looking for a rice and a water number that goes together. That's what this gives me. So I'm going to have to divide. I'm going to have to divide by the W. So to get the constant I'm looking for, I'm going to take a rice number divided by a W number, which is going to end up being 2 over 4.5. Okay. If I put this in the equation, I get the rice is equal to 2 over 4.5 times the W. All I did is substitute in for constant K. 2 over 4.5 is not a nice, neat number, so I left it as a fraction. Now I'm going to say, what is the total number of cups of water needed to prepare 5 cups of rice? Okay, so that means the rice number is 5. So I'm going to get 5 equals 2 over 4/5 times W, and I need to solve for letter W. I'm trying to find out what W equals. So 4.5, and W. So the first thing I need to do is get rid of 4.5. I'm going to multiply both sides times 4.5. Multiply 4.5 times 5, you get 22.5. But you still have the 2 with the W, so equals 2W. Now divide by 2 on both sides. W is equal to 11.25, which is answer choice C. This is a question I actually got off of a state exam, not my question. So you can see how they sometimes can be rather challenging. The V volume of a certain gas varies inversely. So volume varies inversely with the amount of pressure. So I'm talking about volume inversely, so P goes on the bottom and constant K on top. I'm going to have to multiply the V number times the P number to get the constant. When I multiply 175 times 3.2, I end up getting 560 as my constant. So now I'm going to say the volume is 560 divided by the pressure. Now I'm going to use that equation to find what I need. Find the amount of pressure that must be placed on 400 cubic centimeters of gas. So 400 goes here. So you go to 560 over P. I cannot solve with P on the bottom. Multiply both sides by P. I get 400 P is equal to 560. Finally, to solve, I divide by 400, and I get P is equal to 1.40, which is choice B. If T varies inversely as the square of D and directly with M, which equation best represents this? What I see first usually comes first. So T varies, that's going to be equals. When it says inversely, that part goes on the bottom. Okay, so this is on top. Inversely would be the bottom. The square of D is D squared. And then directly, when it says directly means that that's on top. So it's directly with M. Choice B is correct. Identify the following graphs, and I know I don't have them all on here at this minute. Let me see if I can correct that. All right. Looking at the graphs to review our direct and inverse graphs. Direct graphs are made with one movement of a pencil. They are in one part. Inverse graphs are take two movements of a pencil. They are broken, okay? So it's got two broken pieces. Even graphs are what I call even graphs are like people with even temperaments. People love them, so they are like lovers. People who are at odds with each other sometimes hate each other. So these are hater graphs. Now we're always talking about in the vertical direction. So I want you to consider only what happens in the up and down direction, not east or west direction. Positive graphs only exist in the first quadrant, okay? So basically, I'm looking in the top right-hand quadrant to see if it exists there. If it's negative, we'll have no right-hand quadrant. Nothing will be there because it would have been moved to a different quadrant. So that's my test for those three. Number 1, A can be made with one smooth movement of my pencil, which makes it direct, okay? Looking at this one, it looks like this piece is going up the hill and the other piece is going down the hill. It's going in two different directions. These two graphs hate each other, so they must be at odds with each other. So I have an odd exponent. And the last one, I do have a part of the graph that does exist in the top right-hand quadrant, which means that I do have a positive graph. All right. So the equation could be something like y equals, okay, x is on top because it's direct. Odd exponent, which means odd would be like x to the third. Then I need a positive number. I'll just say 2. That's just an example of something it could be. I could have said x to the 5th, x to the 7th, x to the 9th. All right. Direct or inverse. This one is inverse. It's made with two movements of the pencil. It's a broken graph. But this one is going down the street, and this one's also going down the street. So these two people are getting along. They must love each other. So this is an even graph with an even exponent. Lastly, does it exist in the top right-hand quadrant? No. So this one must be what? Negative. This must be negative. So I'm going to draw an inverse equation. So I might say y equals, inverse means x is on the bottom when y is on top. I need an even exponent, so I'll make it a 4 this time. And I need a negative number, let's say negative 20. Just making up stuff. Possible equation for a graph that looks similar to this one. Last one. One movement of my pencil, so this is a direct graph. Okay, this piece is going up, this piece is going up. They're going in the same direction. They must love each other, so this means I need to have an even exponent. And lastly, it does exist partly in the top right-hand quadrant, which means that it has a positive exponent. Okay, all right. So Possibly direct graph would be y equals, x is on top if it's direct, it has an even exponent, let's just say 10, and it has a positive number, let's just say 100. Making up stuff. Positive numbers, even exponents in direct graph, similar to that shape. Okay, match up these terms. Part A is a straight linear graph. So number 2 is linear. This is a classic U-shaped quadratic graph, which would be 3 quadratic. 4 is that V-shaped graph, classic case for absolute value. Absolute value. And finally, we have the one that's half of a sideways parabola, and that's actually the square root graph. Okay, so that's the square root. Okay, you have to know those. You have a sticky note that we made back when we did this. It's a little sticky I gave you, kept it in your book. All right. 5 units up is actually a number added to the outside. So I'm going to actually start with x squared, and I'm going to put the number 5 on the outside. So that's a number on the outside that makes it move up and down. And it moves true to the number, so that's where plus 5 is going to come from. 2 units to the right is actually a number on the inside. So this equation does say y equals, the x is right there inside. I do have my square, and now I'm adding my terms. So it says 2 units to the right. Okay, if you're on the inside, it's kind of like being in jail. You're probably doing opposite of what you should. So 2 units to the right looks like it would go positive, but opposite would be minus 2. Which new function describes this graph? Okay, it would have to be x minus 2 and plus 5 on the outside. That's choice B. Which of the following capital letters of reference simply has one line of symmetry? Has to be letter O. It's the only one that you could draw, and the left half would match the right half. None of the others have any symmetry like that. All right, let's see if we can draw these this time. Minus 1 on the outside means that it goes down 1, but it has the classic half of a sideways parabola. So I'm going to go down 1 unit, half of a sideways parabola, and sketch it. Part B has 2 shifts. The negative in front makes it shift, or makes it flip down. Okay, it's an x squared graph, so it normally has that U shape, and plus 2 is going to make it go up 2 units. So I'm going to go up 2 units and start here. But instead of going up this way, this graph is flipped down, so it goes that way. All right, negative x squared plus 2. This is my V-shaped graph. The plus 4 on the inside makes it go not to positive 4, but actually opposite to negative 4, so it's going to go left 4. And the plus 1 on the outside means it's going to go up 1 unit. So I go left 4, 1, 2, 3, 4, up 1, that's actually my starting point, and the V-shaped graph does not get flipped down, so it goes up like that. Okay, you can always check those with your calculator. So you can check all of these with a calculator. No reason why you should miss these. You should know the translations, but if not, check with your calculators. Under the translation of up right 3, up 2, the point 2, 5 becomes right 2 is an x direction. So I'm going to go right 3, add 3. Up 2 is actually in the y direction. So this was the x, this was the y coordinate. So I'm going to add 2 because up, and that answer would put me at C. A dilation is a size change. So if I change the size by a factor of 3, it's like basically multiplying times 3 on the x and times 3 on the negative 2. Correct answer is D. Identify the coordinate transformation shown in the graph. I think what I was wanting you to do is tell me what I did. It looks like I took this one and I twisted it around the origin that way. That's a 90 degrees counterclockwise rotation. I think this is multiple choice and my choices got cut off. So it should be the one that says rotation. All right, this one was twisted around. 18, the image after a dilation with respect to the origin is negative 10. So how did I go from negative 2 to negative 10? Likewise, how did I go from 6 to 30? I multiplied by 5. 5 is the scale factor of the dilation. Okay, 19, read carefully to make sure you understand the question. A dilation maps 6, 10 to 3, 5. So I'm going to think, how did 6 get to 3 and how did 10 get to 5? Figure out what they did. Then imagine 12, 4 changing to something new. What would be the new point? Well, this looks like it got multiplied by a half or got divided by 2. So if I took this one and divided it by 2, I should end up with 6, comma 2, which is choice C. What type of transformation carried triangle ABC to A prime, B prime, C prime, which means I'm going from here to here? It looks like I have a reflection. It's like I flipped it just across. If I folded my piece of paper across the x-axis, I would end up with that new A prime, B prime, C prime triangle. So it's a reflection across the line, x-axis. All right. How did I go from A prime, B prime, C prime to A double prime, A double prime, B double prime, C double prime, which is from here to here? How did I do that? Did I flip it? Did I twist it? Did I just slide it? The answer is looks like I slid it. I have a translation. This one went 1, 2, 3, 4, 5 units. 1, 2, 3, 4, 5 units left. 1, 2, 3, 4, 5 units left. We have a horizontal, and just sliding it is called a translation of 5 units to the left. Okay, that's the end of unit 1 and 2. Let's now review unit 3 and 4. All right. All we're doing in the first one is adding. When you add, find your like terms. I have an x to the 4th and an x to the 4th. But when you add, you only add the coefficients or the numbers in front. So I'm going to say 4 of these x to the 4th plus 5 of the x to the 4th should be 9 x to the 4th. Do not add exponents. You don't do that until you multiply later. 3x to the 3rd, 8x to the 3rd would give me 11x to the 3rd. Negative 5x squared, negative 7x squared is negative 12x squared. And then I have plus 9 plus 5 is plus 14. And I believe that matches choice B perfectly. Whoops, sorry. Nope, doesn't. Getting ahead of myself. Oh, my bad. C. C is correct on this one. All right. What do I do if I have a subtraction? Notice that you have a subtraction sign between the parentheses. So this is not a lobster claw, it's not a multiplication, but what do you do with that subtraction? Everything after it in the parentheses gets changed the sign. So that's going to become a negative 2x to the 9th, positive, negative, positive. Now I just go ahead and add my like terms. 8x to the 9th, negative 2x to the 9th is 6x to the 9th. Well, that gives me A and B. I can actually wipe out B and D as a choice. Add like terms. I don't have any other x to the 6th, so 12x to the 6th. All right, negative x squared, negative 3x squared is negative 14x to the 2nd. And I believe we have a winner. Just skip a 4th. Okay, plus 8 to the 4th, plus 8 to the 4th, x to the 4th, plus 8x to the 4th, minus 14x. I believe we have C. C is correct. All right, good deal. All right, the plus 8 to x to the 4th is the deciding factor on that one. All right, solve. I want to solve for h. So I want to get everything else away. So the first thing I'm going to do is I'm going to think about dividing out the b. So I'm going to have v divided out the b is equal to 1/3 with a h. All right. How do I get rid of something that's like 1/3? Well, opposite of 1/3 is, or divide by 3 is, multiply by 3. So if you multiply one side by 3, you multiply the other side by 3. You always put that 3 on top. So it looks like I have 3v over b. 3v over b is choice D. Solving for C. First thing I want to do is find C. C is located here. Subtract 32 from both sides. That's the first thing I need to do. I'm going to end up with f minus 32 is equal to 9 over 5 times the C letter. Now I have to get rid of 9/5. I could do it all at once and multiply by the reciprocal, which would be flipping 9/5. Or I could think about it in parts. What's the opposite of divide by 5? Times by 5. So if I times by 5, I have to make sure I times everything on this side by 5, so I have to use parentheses. Now the 5's gone. Now, I have 5 with parentheses, f minus 32, but I still have equals 9 and a c. How do I get rid of 9 finally? Let's divide it out. When I do that, I get 5 over 9ths and f minus 32 in parentheses. I believe that would be choice. Oops, sorry. Nope, it's not. My bad. Got ahead of myself. I believe it is choice D, f minus 32. Decide whether the relation is a function. To be a function, remember, you can't, how does I say that? You can't repeat x's. All right? So let's just check. -3, 1, 4, 9, 12. We didn't repeat x's. Guess what? That one's a function. -8, stop right there. We repeated -8. Every x can only have one y answer, so this one has two y answers, so this one's not a function. Find the domain and range. Domain is a set of all the x's. The range is a set of all the y's. So I'm going to look for 2, 6, 5, 4, and 9. 2, 6, 5, 4, and 9. 2, 6, 5, 4, and 9. Looks like C so far. All right, check your range as your y's. 8, -8, 8, -8, -7, 1, and 3. -7, 1, and 3. Looks like C is correct. You just find your x's and find your y's. All right, how do we do a domain when we have a graph? Well, we're going to read it from left to right, just like we do a page on a book. So the first thing I'm going to do when I go left to right, I'm looking across the x-axis, and that's going to help me find the domain. So I want to imagine coming across here. So far, I'm not at -3. I'm not -2, 3, -4, -3, -2, 1. Finally, at 0, I am being used. And how far to the right? Well, if I go to 1, I'm using it. 2, I have a point. 3, I have a point. And 4, I have a point. At 5, I don't have a point. So it looks like it goes from 0 to 4. The best way to write that, though, is x in the middle, smallest on the left, biggest on the right, backwards, backwards, and it should have an equals because those are solid circles. Solid circles means the endpoints aren't included. Now, when I talk about going up and down from the bottom up, when I go bottom up, I'm talking on the y-axis, which is how we need to think of doing the range. All right. If I go up, I'm not using any points to make my graph. -3, -2, -1, no, but 0. When I finally get to 0, I am using that point. If I go up to 1, I'm using it. If I go up to 2, I'm using it. But if I go up any higher, I'm not using the points. So it looks like the only y numbers that are being used are 0 to 2. But the best way to write that is y in the middle, 0 on the left, 2 to the right, backwards, backwards. These are solid circles, so less than, less than. Keep in mind that this is the point 0, 0, and the point over 4 and up 2, from this x to this x, from this y to this y. Just a reminder of how to look at domain and range on a graph. All right, now apply what you just saw to this graph. What happens when you see arrows? Remember, arrows means that I'm going to keep going up, 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 till I get to all the positive infinity in the x direction. I'm also going to keep going right, right, right to positive infinity in the, the x direction. This one up here was the y direction. Over on his side, I'm going up, 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 so I'm going to go higher and higher in the positive y direction to infinity, and then I'm going to negative infinity in the x direction. Anytime you have infinity or arrows pointing in two different directions, I'm going to end up having all real numbers. So it looks like to the left, coming from the left, I'm using all of the x's, using them here, and I'm keep going all to the right. So it looks like I have all real numbers on the x's. Okay, this one doesn't have all real numbers on the x's. This one doesn't have all real numbers on the x's. So now I'm doing the C and D. Now, I'm going to go, remember, bottom up to do the range. From the bottom up, -4, no, -2, no, 0, no, 1, no, 2, no, 3, no, 4, whoops, sorry. When I get to 2, I finally get to a point when I can do what? Go over and finally touch the first point on my graph. And if I keep going up to 3, yep, go over, I touch it twice. If I go up to 4, yep, touch it twice. Go up to 5, yep. So it looks like from every point, as long as I keep going, I'm going to use points on the graph. But where do I start? It looks like I go from 2 and up in the y direction. So that would be from 2 to y, all the way to positive infinity, backwards, backwards. Yeah, it does equal there. You can't say equals on infinity, though. Can't do that one. Never can do equals on infinity. So if you switch that around, same as y is greater than 2. All right, that one matches. T. Give the value of the function. All I need to do is substitute in. 6 is now my new input. So if this is my new input into the function, I'm going to put it right here. So 9 times 6, 54, plus 8 should be 62. Okay. My new input into the function is -3. Under the square root, what's -3 plus 12? Looks like that's going to give me the square root of 9. Square root of 9 is +3. Given the function f and g, find the indicated operations. When it's written f plus g, I take the f function, write it down. I take the g function, write it down. And then what am I going to do? I'm going to add them. So I'm going to put a big plus sign between them. And now I just add like terms. -5x, -2x is -7x. 8 and 5 is +17, or +13. So choice A is correct. What am I doing in 13? 13, I am subtracting the functions. You got to subtract them in that order. So I'm going to write down my f function, write down my g function, and subtract them. When you see a subtraction in front of parentheses, you've got to make sure you change those signs. So after you change your signs, 8x minus 2x is going to be 6x, and -6 plus 8 is +2. So 6x plus 2 is choice D. Let's keep going. How do I multiply two parentheses? Well, I'm going to have to remember to FOIL it out or lobster claw. If you FOIL it out or lobster claw, you'll end up with 4 terms and you add like terms. 4x times 4x is 16x to the second. You do add when you start multiplying, so add the 1 and the 1. 4x times 28. No, that's, or 7, that's 28x, my bad. -7 times 4x, -28x. Then -7 times +7 is -49. My middle terms actually add up to be 0, so they cancel out. So all I have left is 16x squared minus 49, choice A. Find the greatest common factor. I didn't skip a page, did I? Oh, I sure did. Thought maybe I did. Let's finish that page and we'll come back. So it looks like I have skipped a page by mistake. All right, find the greatest common factor. Greatest common factor, we're going to all of those, looks like it is 2, and there's 1x. So I'm going to divide, just like I'm going to divide out 2x, divide out 2x, divide out 2x. If it goes into 14, 7 times. So it's like DS rule. Divide bigs, subtract littles. X from x to the third is x to the second minus 2x plus 5. Close parentheses. And that matches 2x on the outside. Looks like that's choice A. Factor the trinomial. Factoring the trinomial means I'm going to try to factor the first term. X times x gives me x squared. I'm going to factor 42. When the last term is negative, I want to subtract to get the middle term. So that's going to be 1 times 42, 2 times 21, 3 times 14, 6 times 7. Which one of those sets of factors subtract to give me -1x? It's 6 and 7. The bigger factor needs to be the negative. And if you check the middle, you get 6x. If you check the outers, you're going to get -7x. And sure enough, that does give you -1x. Always, always check the middle term. So it should be +6 minus 7. +6 minus 7 is choice A. All right, this one. The last term is +7. So I'm going to factor x squared to x and x. The only factors that give you 7 is 1 and 7. Because it has to add up to be a +8, I'm going to have 1x and 7x, which does add to give 8x. So it's +1 and +7, choice A. Factor the perfect square trinomial. That means that I'm going to have perfect squares in the front and in the back, and I'm going to check the middle term. So, I'm telling you it's a perfect square trinomial. What multiplies to give me 81x squared? I believe it's 9x times 9x. So 9x times 9x. What about 16? What's a perfect square? That would be 4 times 4. And when I do 4 times 4, it has to add. So I'm going to have +4 plus 4. If you check the middle term, you get 36x. Check the outers, you get 36x, which of course adds to be 72x, which checks your middle term. And the answer is 9x plus 4, and you have 2 sets of parentheses just alike. Factor the difference of 2 squares. These are special factors where you do not have a middle term. So if I factor this completely, this is going to factor into x squared times x squared, and that's going to factor into 4 times 4. So if I start this way, I'm going to have x squared times x squared and 4 times 4. In order to have no middle term, you're going to have 1 plus and 1 minus. Just like we did when we did number 18. We had 1 plus and 1 minus, so our middle term canceled. So it does say factor completely. Let me check. Uh-oh, I have another difference of 2 squares. Inside my answer is another difference. So I can actually factor the second parenthesis again. So I'm going to get x squared plus 4, because that won't factor again. This part will factor again into 2 sets. X and x is x squared, 2 and 2 is 4, 1 plus and 1 minus parenthesis. And that would be choice B. Which equation has exactly one real solution? In order to have one real solution, the 2 parentheses must be alike. And I actually think that's pushing us a little into chapter unit 5, but I guess I got this one out of place. The only one that will factor into 2 parentheses that are alike is, let's just check this one, 2x and 2x, 3 and 3, and that is going to be 6x and 6x. Nope, that gives me 12x. Can't be A. That one has a subtraction sign. It can't be that one. That one has a subtract 9. It can't be that one. I think it's this one. 2x and 2x, 3 and 3, plus, sure enough, 6x is 12x. 2x plus 3 and 2x plus 3. If you set each one equal to 0 and solved, guess what you would get? You would get the same answer for both. You get negative 3 over 2, and this one would also give you negative 3 over 2. So it looks like the last one. The ones that give you exactly one real answer are perfect square trinomials. When they're perfect square trinomials, they're identical in the 2 parentheses, and they only give you one solution when you solve. All right, oops, we were supposed to go back to that page I skipped. All right, 14 is a composite. I'm going to take the f function and the g function, combine them together to get one answer. In this case, I'm going to start with the function closest to my input. I'm going to put 2 into the g function. So if I put 2 into the g function 2, my g function with the 2 in it is 8 times 2 minus 10, which is 16 minus 10, which is 6. Now I'm not finished, because remember we have to put the function into f the second time. So I'm going to do 13 times 6 squared minus 3 times 6. All right, and if you type that into your calculator, I believe you get D. Find the product. This is where you lobster claw, which we just did, only we did it out of order. All right, x times x, x squared. X times negative 3, negative 3x. Negative 12 times x is negative 12x. And negative 12 times negative 3 is positive 36. Add like terms, I get x squared in the front plus 36 in the back. And when I add, I get negative 15 with an x. Choice D is correct. All right, next, multiply x times x, x squared, x times negative 1 is negative 1x, positive 4 times x, and positive 4 times negative 1 is minus 4. Add the terms in the middle. In this case, you'll end up subtracting. I'll get x squared, positive 3x minus 4. Choice A. What does it mean when you see x minus 14 squared? It means I have 2 parentheses just alike. So I have an x minus 14 parenthesis and another x minus 14 parenthesis. I have 2 parentheses just the same. So you multiply them out. X squared minus 14x minus 14x again plus 196. So when you add like terms, you get negative 28x in the middle plus 196 and x squared in the front. And I believe that is choice D. Yep, choice D. So we just finished 3 and 4. All right, we're going to solve. This is when we were doing our quadratic unit. So the first thing we're going to do is get x squared by itself. If I get x squared by itself, I need to get rid of the 3 and the 5. So first thing I'm going to do is subtract 5 from both sides. And I'll get 3x squared is equal to 12. Then I still have to get x squared by itself, so I got to get rid of the 3, so I'm going to divide it out. I end up with x squared is equal to 4. Then it says, I gave you little hints, then square root of both sides. I get x is equal to positive and negative 2, because it does say, don't forget, plus or minus. So the answer is actually D. The answer is actually choice D. All right, number 2, square root method again. Can you follow the same directions? Get x squared by itself. So how do I get rid of the 5? Divide out the 5. X squared is equal to 100. Take the square root of both sides. Square and the x cancel. Square and the square root cancel. I get x is equal to 10. Don't forget plus or the answer is A. Solve the quadratic equation by factoring, which means set it equal to 0. Factor into two sets of parentheses, split, and solve for two possible answers. So first thing I'm going to do is move everything over here, subtract x, and subtract 42. If I do that, I'm going to end up with x squared minus x minus 42. All right, that's now set equal to 0. So I've done the first thing. Factor into two sets of parentheses. Okay. Anytime you multiply one thing times another thing and you have an answer equal to 0, the only way you can do that is if one of the factors is a 0. So it could be the parenthesis, that's the first one or the second one, but I need to factor it. I believe 7 times 6 is 42, and then if you do negative and positive 6, you end up with negative 1 in the middle. Now I'm going to split and solve. So take the first one, x minus 7, set that equal to 0. Take the second parenthesis, x plus 6, set that equal to 0. When you move it to the other side, you get x is 7 and x is negative 6. So I get a positive 7 and negative 6. That's choice C. Factor out the greatest common factor, split and solve. So it's already set equal to 0 and I'm factoring it. I don't have three terms, so I can't factor into two sets of parentheses, but I can do a GCF. What's in common between 8x squared and 7x is only the x. So I'm going to factor out only an x. So if I take out one x, I have 8x left minus, and then I have only a 7 left equal to 0. I actually do have two things multiplied, and the answer equals 0. So I'm going to split it, and I'm going to set each one equal to 0. So the first one says x equals 0. First answer is easy. Second one's 8x minus 7 equals 0. Can't see that one easily, so I'm going to have to go through and solve it. I'm going to add 7 to both sides. I'll get 8x is equal to 7. Then I'm going to divide by 8, and I get a fraction. X is equal to 7 over 8. So my answers are 0 and 7/8. 0 and 7/8, I believe, is choice C. 0 and 7/8, not negative, positive. All right, number 5, I'm factoring. Okay, so I'm going to work out number 5 down here so we have more room. If you factor number 5, x and x give me x squared. I'm going to try and set it equal to 0. What multiplies to give 60? It subtracts to give 40, because the last term is negative, so you're going to subtract to get 4. So 1 times 60, 2 times 30, 3 times 20, 4 times 15. 68 doesn't go into 60. What else? 6 times 10. I think that's it. Which set of factors are difference of 4? So it's going to be 6 and 10. So 6 and a 10. The bigger factor needs to be positive, so it's going to be plus 10 and minus 6. Split and solve. So when I split, x minus 6 should be the 0, or x plus 10 could be the 0. So that's going to solve to give me x is positive 6, and x is going to give me negative 10. Positive 6, negative 10. Positive 6, negative 10 is here. All right, number 6. I'm going to solve number 6 right here. First thing I have to do is get it equal to 0, so I have to subtract 4. 2x squared minus 7x, subtract 4 equals 0. So the 4 became negative when it came over. All right, I'm going to have to make sure this time that I do some trial and error. What two things multiply to give me 2x squared? 2x times 1x. It's the only thing you can have is 2x and 1x. What multiplies to give you 4 is 1 times 4 or 2 times 2. I think if we check, 2 and 2 won't work. I believe it's 1 and 4. The last term is negative, so I'm going to subtract to give 7. So I'm going to put the 4 here and the 1 here. How do we check again? We're going to do inners and outers. That's going to give me 1x. That's going to give me 8x, which sure enough would subtract to give me 7. And so the 8 needs to be negative, so I'm going to have to put a negative in front of the 4 and a positive in front of the 1. Now that I've got it factored, now I'm going to split and solve. 2x plus 1 parenthesis, that could equal 0, or x minus 4, that could equal 0. This one's easy. I know that's going to be x is positive 4. Here I'm going to have to do a little work because I don't see it as easy. 2x is equal to negative 1. Dividing by 2x is equal to negative 1/2. So I did get a fraction. Negative 1/2 and positive 4. Negative 1/2 and positive 4 is choice B. All right, solve the equation using the quadratic formula. Opposite of B, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. All right, all you have to do is find a, b, and c. A is the coefficient in front of x squared, which is a 7. B is the coefficient in front of x, that's going to be a 10, and C is the coefficient, well, the number of the constant at the end with no x, and that's 2. All right, we're going to substitute straight into the formula. Opposite of B is opposite of 10, which is negative 10, then the plus or minus part, then the square root with a big long one. Now I'm going to square the B number. 10 squared, 10 times 10, I like to do that ahead of time, is 100. Minus, the 4 is in the equation, so I'll keep the 4. The 2 turns out, or the A turns out to be a 7, and the C turns out to be a 2. All of it divided by 2 times the A number, which is 7. Now, at this point, what I want you to do is put this in your calculator, not the square root. Just type that in your calculator, because the first thing I want you to do is give me the radical form, when we're going to leave it in the radical form, because this one doesn't work out nice and neat. I believe 100 minus 4 times 7 times 2, 4 times 7 times 2 is 56. 100 minus 56 is 44 over 14. Doesn't match any of my answers. But we've done enough that we should know how to handle this. How do you square root 44? How do you break that down? Well, perfect square would be 4 times 11. 4 comes out as a what? A 2. 2 square root of 11. So I'm going to break that down. So now I have negative 10 plus or minus 2 square root of 11 over 14. What happens here is I can factor out a number and actually cancel out a 2 from every part. We didn't do this quite so much, but it's something that you need to be aware of. All right, here we go. If I factored out a 2, I'd get 2 on the outside, and I'd end up with negative 2 goes into negative 10, negative 5 times, plus and minus. 2 goes into 2 root 11. The outside numbers can divide, but I can't do anything with the inside. And then on the bottom, I'd have 14. I believe what happens is 2 goes into 14 7 times. Outside numbers can be divided by outside numbers. So this part right here is my final answer in radical form. And which one of those does it match? Negative 5 minus and negative 5 plus. So choice C is correct. All right, how do we simplify square roots? It's been a little while since we've done these. What you're going to do is you're going to break down 500 into like 105. 100 is a perfect square. So remember, look at the board, check out your perfect squares. Pick out the biggest perfect square you can. It goes into your number. 100 is the biggest. So what comes out is going to be a 10. For every 2 A's, I can bring out 2. So I can bring out 1. Sorry, I can bring out 2 A's. There are 5 B's. I can bring out 2, but there's going to be some things left inside. Well, the 5 is still left inside, and one of the B's, because of an odd number, is left inside. So 10A squared B squared, 5B. Choice B. Simplify square root of 15. Is there a perfect square that goes into 15? Well, if you find 15, it's between 9 and 16. 9 doesn't go, 4 doesn't go. Guess what? 15 does not work out. It is already simplified. It's a little bit of a trick question. C is correct. 10 is also a little bit of a trick. Can you take the square root of a negative? Guess what? Cannot take square root of a negative. If you do it, your calculator will give you a big error. You cannot take the square root of a negative. There is no number times itself twice that will end up with a negative answer. All right, 108. We need to be able to go ahead and divide down 108. It turns out 108, it turns out when you break down 108, if you start at 100 and come back, 100 doesn't go, 81 does not go into it, 64 does not go into it, 49 doesn't go into it. I'm thinking of perfect squares. So guess what? 36. It does go into 108 3 times. So I can break it down to 36 times 3. What comes out is a 6. 6 on the outside, 3 left on the inside. B is correct. All right, break down 75. 75 is 25 times 3. And for every 2 x's, bring 1 out. So guess what comes out? 5 comes out and 1x comes out. These numbers are used. The squares are used up. The 3 is still there. So a 5 and x on the outside and 1 3 on the inside. I guess that is A. All right, we have our rational exponents. The thing to remember is when you have like 4/3, the top number is your power and the bottom number is your root. So I'm actually going to take the third root of 27. That means I'm looking for a number times itself 3 times. It's going to give me 27. And then I'm going to raise the answer to the second, or excuse me, to the 4th power. All right, so what number times is 3 times self 3 times is 27 is a 3. So that's going to be a 3. Then I'm going to raise 3 to the 4th power, 3 times 3 times 3 times 3, 4 times. Turns out to be 81. You could also type 27 to the 4/3 power, and it'll tell you the answer is 81. So you can check that with the calculator. So you can check with a calculator. I did it by hand, but you can also check by your calculator. Okay, multiplying radicals. You multiply outside times outside, keep it outside. Inside times inside, keep it inside, and then try to see if you can simplify. So outside times outside, 15x. Inside times inside, it's going to be 6 times 3 is 18, keeping it inside. X squared and x is x to the 3rd. Y and y to the 3rd is y to the 4th. Now I'm going to see if I can break this down and bring some things out. That's going to be 9 times 2, so guess what comes out? 3 comes out. There's already a 15 out there, so when you multiply, you get 45 on the outside. So multiply those two numbers on the outside. 2's left. For every 2, bring out 1, so I can bring out an x. There was already 1 out there, so if you bring 1 more, now you have x to the 2nd. You still are going to have 2 and 1x left. For every 2 x's or y's, bring out 1, so I can bring out 2. 45 x squared y squared with a 2 and an x. There we go. Subtract. When you add or subtract, you can only add or subtract if they are alike. So they must be alike. All right, they must be alike. So square root of 7 is alike square root of 7, so I can only add the numbers in front. So we add or subtract numbers in front. All right. When you add or subtract the numbers in front, you get 4 with the square root of 7. Okay, in 16, it looks at first like I can't add because I got a 6, square root of 6, and square root of 150. They are not alike. But what I need to do is I need to simplify and then see if I can. So let's just see if I can. It looks like I should be able to. Okay, 6 does not break down, but 150 does. Okay, 25 goes into 150. So 25 goes into 150, I think, 6 times. So I have a 7. So if you break that down, 5 can come out. There was already a 7 there. So that's going to give me 9 squared root of 6, which is the same thing, plus 5 times 7 is 35 now on the outside, and then what's left on the inside is a 6. Now I have like terms. They both have square root of 6. So 9 plus 35 is 46 with the square root of 6. Oops, yeah, 44 with the square root of 6. Can't add. It's getting late in the day. 44 square root of 6. All right, use the quotient rule to try to simplify. Turns out, don't really have to worry too much about the quotient rule. 64 and 81 do not divide. But because that square root goes over top the entire fraction, it goes with the top number and it goes with the bottom number. So if I wanted to think of it as the square root of 64 and the square root of 81, I get 8 and I get 9. 8 9s. All right. This time we're going to divide. 112 goes into 4 goes into 112. How many times? 28 times. So if I do that, I get square root of 28. Divide the inside, divide by inside, divide and keep it inside. X to the 4th over x, remember this one x would cancel out all but 3 of those, so I have x to the 3rd here. So after I divide, I get 28. Now I should be able to simplify that into 4 times 7. Take that as a 2. So 2 on the outside, I can bring out 1x, x on the outside, a 7, and 1x left. All right. Okay. Rewrite as a radical. Remember, this is my power, and this is my what? This is my root. All right, so that's the same thing as the second root of 11 to the first power, but I don't have that exact thing here. Please remember that under the square root, if you just write square root, it's implied the little 2 is in there. And even though you don't put 11 to the first, it's still 11, so that makes the answer C. All right, rewrite as a radical and simplify. Same thing again. 1/2 power is the square root, so that is my second root or my square root because the bottom is the root. Okay. So square root. Parentheses tell me everything's under the square root. And this is to the first power. So what's the square root of 49? Y to the 10th. Well, comes out as a 7. This comes out as a y to the 5th. There is no radical left after you bring everything out. All right, rewrite the rational expression with exponents, or rewrite the expression with exponents. Okay, this is understood to be a second root. Remember, it's power over root. All right, 14 and x are both in there, so I'm going to keep those parentheses. Power is the fifth power over the second root, so over a 2, and that matches C. I have to have my parentheses. That's what makes this one not be correct. It doesn't have parentheses. First thing I want you to do is I want you to think about, what do I do if I simplify the square root on the bottom? That's actually the fourth root in this problem. So that's w to the first power, to the outside is a root. So let's keep it over 1 for now. So it's going to be w. Power is 1. The root is 4. Now it's 1 over w to the fourth, but I don't have that. I do know that if I bring it up to the top, it goes from a negative exponent or positive exponent to a negative. It's almost like every time it crosses that bar, it changes sign. So it's going to be w to the negative 1/4. All right. Multiply. Outside times outside, inside times inside is 12 root 2. Outside times outside, inside times inside is 15 root 12. I can simplify that into 4 times 3. 2 comes out. 2 times 15 is 12 root 2, because you can't do anything to that. 15 times 2 makes me 30, and I have a 3 underneath. All right, that looks like choice B. Solve the radical equation. When you solve, you want to get it by itself. So get the square root by itself. And then how do we solve? How do you undo a square root? You're going to square both sides. All right. So first thing I want to do is get the square root by itself. So I got to get rid of plus 2. I'm going to minus 2. So I get the square root of 2x plus 3 equal to 11. Now, square root's by itself, so I'm going to take the step of squaring both sides. What happens when you square a square root? This cancels this. What was underneath comes out. So I get 2x plus 3. If you square one side, though, you got to square the other side. So when I square 11, I get 121. So now when you subtract 3, you get 2x is equal to 118. Divide by 2. X is equal to, I believe, 59, which is choice D. All right. Finally, the last little bit. These you can type in your calculator, or you can do them in your head. -7 times -7 times -7. 3 times. The negative stays with the 7. So that's going to end up being a negative answer, and 7 times 7 times 7 is 343. It should be negative. This time, the first thing that the exponent touches is a 6, so it only goes with the 6, but it doesn't go with the negative, so the negative on the outside, then 6 times 6. This is going to give me 36. Then go ahead and put the negative back on there. You should get negative 36. Same thing here. Anything to the 0 power is a 1, but the negative doesn't go with the 11, so it's going to be negative 1. 5 to the negative 3. I need to make that negative exponent positive, so I'm going to bring it to the bottom. 1 over 5 to the positive 3. And 5 times 3, or 5 to the third power, 3 times is 125. 1 over 125. Simplify the expressions. Please remember you can't multiply the 7s. Not until you get rid of exponents. So in this case, all I can do is add the exponents, keep the same base, okay? Keep the base. You can check this with your calculator to confirm it, but it should be 7, keeping the base, and then 7 plus 3 will be 7 to the 10th power. Do not multiply the 7s. Okay, inside exponent, outside exponent, you multiply across the parentheses. That's 4 to the 6th power, and when you take 4 to the 6th power, you end up with 4,096. All right. All right, let's keep it going. I can't keep negative exponents, so this negative 2 exponent comes down here, and I get x squared over y squared. Choice C. Okay, first thing I need to do is get rid of the parentheses. So inside power, outside power, or power times a power. You multiply inside and outside, you get negative 45 exponent. Cannot keep it negative 45, so the x and the exponent come downstairs. 1 over x to the positive 45. That's how you make a negative exponent positive. Number 9, we're going to remember our mama rule. Multiply those big numbers and add those little exponent numbers. So negative 6 times negative 3 is 18, positive. And then x to the third, x to the 9th, add exponents, you get x to the 9th. Oops, sorry, it's not that one, it's C. It's not negative. All right, here we go. 10, got a couple things. I'm going to work inside first. 1x on top would cancel all but 4 on the bottom. So I'm going to end up with x to the 4th on the bottom. 1 y on the bottom will cancel one of those on top and leave me with y to the 2nd on top. I still haven't done anything to my negative 2 exponent. Now you could do a couple of rules in different order here. I'm going to go ahead and take everything, it's a piece of the outside exponent. You multiply across the parentheses. Y to the negative 4, x to the negative 8th. Every negative exponent goes up, that's on the bottom, and the one that's negative on top comes to the bottom. When I do that, I get x to the 8th over y to the 4th. Okay. Mama rule again. 4 negative 4 times that's going to be 36. Add exponents, you get x to the 5th and y to the 7th, because that does consider a 1. All right. All right, number 12. We do need to divide. So 7 goes into 5. Divide bigs as normal. I get 5. I have more x's on top. There's 1 more. I have more y's on top. There's 3 more. So fx y to the 3rd. Piecewise function. I kind of forgot to do this one back, I think, in the 2nd unit or 3rd unit, so I'm going to go back and pick it up. Look right here at my function. This is broken into 2 pieces. I use the top piece, the top equation, if the x's that I'm going to use are less than 4. I'm going to use the bottom piece if x's are greater than 4. So what you got to do is you got to look and see what your input is. So this is my new input. And you ask yourself, is 6, is it less than 4? Or is it greater than or equal to 4? Well, it's greater than or equal to 4. So I'm going to end up using this piece. Okay, it falls right here. So only one piece is ever used. So I'm going to put the 6 into the second piece of the piecewise function, minus 3, which is 30 minus 3, which is 27. Okay, write the equation in its equivalent exponential form. This is where I need to remind you to snail it, not smell it, snail it. Start at the base. Start at the base. All right. 5, 2nd, 25. That tells you the order. Touch the 5 first, the 2 second, and the 25. 5, 2, 25 is B. 4, 2, and x. 4 to the 2nd power equals x. 4 to the 2nd power equals x is D. Same thing with the other way. Find the base. The base is 7, then 343, then 3. So log to a base 7, 343, that's 7, 343, and then 3's last. All right, log base 6 of x equals 3. Or of, yeah, log base 6 of x equals 3. Yep, there we go. All right, we can always think of this. Remember, every time you press the log key, you're looking for a power of 10. So 10 to what power x, just like equal x. 10 to what power x is equal to 10,000. So count your zeros is an easy way, or you can type that in your calculator. The answer should be 4 zeros. 10 times 4 times. Solve for x. X to the 2nd power equals 81, so I'm snailing it to figure out what it looks like. So x to the 2nd power equals 81. The answer is going to be x equals 9. 5 to the 3rd power equals x. 5 to the 3rd power equals x. X should be 125. Short answer. I made these short answer. All right. 5 to the x power is 1 over 25. What kind of exponent do we need to move something to the bottom? I think we need a negative. So 5 to the 2nd is 25. But 5 to the negative 2nd, remember, you move that to the denominator, would be 1 over 25. So the answer is, the exponent I'm looking for is a negative 2. It's a negative exponent that moves things to the bottom. Okay, starting with the big number 64, raising it to the 1/2 power equals x. Remember, 1/2 power is the same thing as square root of 64. And that means x that I was looking for is 8. All right, solving. We had some strategies for solving for bases of 10, solving for exponents. First thing I have to do is I want to get the exponent part by itself. So if I get the exponent part by itself, I got to get rid of the 5. How do I get rid of the 5? I'm going to divide the 5 away. Remember, you can't multiply the 5 and the 10 because the 10's got an exponent. So it's 10 to the x's left. And 500,000 divided by 5, I believe, is 100,000. Now, the second strategy says try to make them both base 10. I believe 100,000 can be changed to base 10. So 10 to the x power is 10 to what power? Well, count exponent zeros. 1, 2, 3, 4, 5, so it should be 10 to the 5th. The only way this 10 can be equal to this 10 is if these exponents are the same. So the answer for exponent of x must be number 5. All right, let's continue. X was 5. Solve. This time I'm solving for 2x, so my exponent part's by itself, but I can't get base 10. So I'm going to have to employ the last strategy. The third strategy that we learned said take the log of both sides. So if you take the log of both sides, what happens is I'm going to squeeze the word log in here with the 10, squeeze the word log in front of 250. I get log of 10 to the 2x is equal to log of 250. Now remember, that's log base 10 of 10. This is a log and an exponential together. Remember, they are they're two functions that cancel each other out. So the log and the 10 cancel, so the 2x comes down as a big 2x, but the log of 250 does not cancel. So this is where I would need to grab my calculator, divide by 2. So you're going to type in log of 50 in your calculator. Make sure you put parentheses around the 250, and then hit the divide by 2 key. So log of 250. Log, parentheses, I'm doing it on my calculator, 250, close parentheses, divided by 2. I get a decimal. X is equal to 1.199. Yeah, which I could say is 1.2. You will get decimals. All right. Population of a large U.S. city is 12.5 million and growing according to the function. What will be the new population in 10 years? So what that is I'm asking you, and I'm giving you a new time. I have a t here, so basically I'm just going to substitute in the population. Starts at 12.5 million. It multiplies times 10 to the 0, 1, 2, 5. That is supposed to be an exponent times 10 years. So type that into your calculator. 12.5 times 10 raised up to the 0.0125 times 10. That's all should be up high. And I get an answer of 16.66. 16.66 or 16.7 million people in 10 years. All right, so I just substituted in. Now we're going to begin a little bit of our new geometry stuff. When two angles add up to be 90, they are complementary. Okay, it's a vocabulary word that we had on our sheets from Tuesday. When two angles add up to 180, they are supplementary. All right. All right, it says if an angle measures 20 degrees, then its complement is. So I need to think what angle would add to 20 to make it 90, and the answer is 70. And then it says the supplement, so I need to add to 180. So what angle adds to 20 that would give me 180? And the answer is 160. If with one angle of a right triangle measures 62 degrees, that's the right angle. So if you know if it's the right angle, that one already measures what? 90. And the other one, it says measures 62. So I'm actually drawing a picture to help me see it. What is the measure of the other acute angle? So I would say 90 plus 62 is equal to, plus the x angle equals 180. So you should add them up and subtract from 180. So if I add them up, I'm going to subtract 152. X should equal 22, 28. Yep, 28 degrees. X is 28. All right. This is when we did our sine, cosine, and tangent. Mark side length 2 and side length 9 with adjacent, opposite, or hypotenuse. So here's my angle. This is my reference. So across from it is my opposite, and beside of it that touches it is the adjacent. I do not have anything, but this side would have been labeled as the hypotenuse, but I don't need it because I don't have anything on it. Which trig function would allow you to solve for angle theta? Well, which trig function relates opposite to adjacent, and that is TOA, so that would be tangent. Okay, use your foldable. You can use it on the exam tomorrow. Write the complete trig sentence. Tangent of angle theta, copying this straight out of our foldable, should be 9/2. Solve for the measure of angle theta. So theta equals. So remember, if you have the answer, but you're trying to work backwards to get the angle, use inverse. So you're going to use that second key, then do tangent. So it's going to be inverse tangent, which is going to look like a -1 on your screen, of the answer 9 divided by 2, and then press enter. So if you do that, I got 77.47, so 77.47. If you round up to the nearest degree, it would be 77 degree. Calculator exercises. When do you use regular and when do you use inverse? Now, the first thing I need to remind everybody is make sure that you are in degree mode on your calculator. So find the little mode button at the top next to the second key and change it to degree mode. So if it's got the angle given, you're going to use regular cosine. So you're going to type it in just like you see it. So I want cosine 60, and that's going to give me 0.5. Sine 45 is 0.707, and tangent of 45, I believe, is 1, perfectly 1. All right, this time it says cosine of something equals 0.866. This time I have the answer, but I do not have the what? I have the answer, but I don't have the angle. So the angle is missing. This is when you got to use what? Use inverse. So I'm going to type it in as cosine inverse of the answer 0.866, and that should tell me what the angle is. So inverse cosine of 0.866, tell me it's 30. So 30 degrees. All right, sine of what angle is 0.9848, so I'm going to use inverse. I'm going to type it in as inverse sine, 0.9848. So inverse sine of 0.9848. I'm getting 79.8 or 99, which is 80 degrees. Tangent of what angle is 3/4? I'm going to use inverse tangent of the answer 3/4 and type it in as 3 divided by 4. And I'm going to get 36.8, which is 37 degrees, rounded to the nearest degree. Those are our calculator exercises. Almost to the last point. Set up a trig sentence to solve for x in the following. First thing we need to do is find an angle. Across from that, I'm going to label x as opposite. And 225 is actually across from a 90 degree. That makes it hypotenuse. If you check your foldable, I think so. Sine is opposite to a hypotenuse. So I'm going to use sine. Sine of, and always what comes after, it's always an angle. Sine of an angle. So the angle is 35 degrees. Then I have a bar, and I'm going to put the opposite over the hypotenuse just like it shows me in my foldable. That's the definition. So opposite would be the x, and the hypotenuse is 225. Okay, so those little extra things are not necessary. This is my trig sentence right here. All right, this is my trig sentence. So now, how do I solve for x? Well, x is in the numerator. So how do I solve for x? I'm going to multiply by 225. So if you multiply one side by 225, you're going to multiply the other side by 225. Type it straight in like that. 225 times key, sine key. It opens up parentheses, put 35, close your parentheses. So if you type in 225 times the sine key, 35, close parentheses, I'm getting 129. So x equals 129.05, which I'll say 0.1. All right. This one, 50 is my angle. This x is my hypotenuse, okay? 15 is actually touching my angle, so it's adjacent to my angle. Which trig function is adjacent to hypotenuse? I think you look for chi, which is cosine is adjacent to hypotenuse. It's cosine. What comes next is always an angle. So an angle is 50 degrees. Then what comes next would be the adjacent number over the hypotenuse number. So that's going to be 15 over x, okay? Those parts here are not really part of the trig sentence. This is the trig sentence that we're trying to write. This time I'm going to solve for x. There is a shortcut that says you move what's up here to the top and what's down here. You're going to end up dividing to get your answer. 15 divides by cosine of 50. All of these solving have one step. So I'm going to type in 15 in my calculator. Divided by cosine, open parentheses, and make sure you close parentheses around 50. That just always make sure you'll get the right answer. So I get x is equal to 23.3. All right, the last one says solve for x, but I do not need trig this time. Oh, I have a bar here with a mark, another line here with a mark. That means two sides are equal. So if two sides are equal, then two angles are equal. So this angle over here, this angle over here are the same. So I'm going to say 2x plus, now what does this little straight stair step mark mean? That means that I have a 90-degree right angle. So the 2x's added to 90 should equal 180. So 2x is equal to 90, because you're going to subtract 90 from both sides. So if you divide by 2, guess what? X equals 45 degrees. Those two base corner angles are 45 degrees. Didn't really need trig. It was just something I remembered about triangles. Which statement about the triangle must be true? Okay. Do you remember this is called a mid-segment? It is in the middle of the line. Notice the bar. This side's equal to this side, so it's in the middle. That's a midpoint. All right? These bars are equal to this one, so that means that this is also a midpoint. If those are midpoints, then that is a mid-segment. It must be half the length. So I believe there's one that says S to T, and it talks about Q to R. And it says if you take 2 times QR, you're going to equal ST. That is the one we need. Okay. Use what you know about angles to form from parallel lines to find the following. First thing I'm going to do, trace my angles. I have an F shape. Which ones are F-shaped? Those are corresponding angles. Corresponding angles are equal. So I'm going to set 75 equal to 11x minus 2. I'm going to add 2 to both sides. I get 77 is equal to 11x. Divide by 11. X is equal to 7. So x is equal to 7, and they are corresponding angles. All right, so just filling in my blank. Okay, the next one. If I trace this angle, and I trace the other angle, I get the U shape. Okay, those are same side, interior. They're in between the lines on the same side of the transversal. Solve for x. This time I'm going to have to add to 180. So I'm going to say the 20x plus 5 angle plus 24x minus 1 equals 180. Okay, add my like terms. I get 44x plus 4 is equal to 180. Subtract 4 from both sides. 44x is equal to 176. So 176 divided by 4, 44, is 4. X is equal to positive 4. Last one is C. C. Trace my angles. This one and this one makes a backwards Z-shaped. Z-shaped angles are, let's see if I can get one right. Z-shaped angles are alternate interior angles. Alternate interior angles. Alternate interior angles are equal. So that tells me 60 is equal to 8x minus 4. So when you add 4 to both sides, you get 64 is equal to 8x. Divide by 8 on both sides, x is equal to 8. X is equal to 8. Okay, it's my parallel lines review. By what method are the following proved congruent? You have 5 methods. So I'm going to mark them with letters. This is a side. This is another side. That's a third side. 1 mark, 2 marks, 3 marks. So that one is what? Side, side, side. Now it's given me the letters. R, S, T. R is between the 1 mark and 2 mark. So the one that's between the 1 mark and 2 mark is X. And then S is between the 2 mark and 3 mark. So I'm coming over here between the 2 mark and 3 mark is Y. And then, of course, Z would match up to T. So Z is between the 1 mark and the 3 mark, which would be T. Okay? All right, B. Marking side, side. It is a right triangle, but it's not HL because I don't have the hypotenuse. There's no hypotenuse listed. So it's not HL. But I can say that angle is equal to that angle, so that's going to be side, angle, side. Now, U, V, and W. U is at the right angle, which would match to X. V comes out to the corner where there is no mark, and it's across the 1, so it's going to go to Y. And then Z would be coming back over. Yeah, okay. C. C, they overlap a little bit. Now, there's something I can mark in this one that's not marked. Do you see X marks the spot? So that angle is equal to that angle. So I can mark that. Now I can say I have a side, I have an angle, and I have another angle. So that one's angle, angle, side. RST. R is in the corner. RST, okay, I start at the bottom, so R is the corner angle, so that's C. S comes up, so it's S, and T goes up to E. Okay. DEF. Oh, look, right angle. Oh, I do have hypotenuse this time, and that is a leg, so that one is going to be by HL theorem. And so what I'm going to do is DEF, D is the right angle, so V is the right angle. E goes out to the sharp corner, which is W, and then X is last. That is my review of parallel lines. Solve the following for mid-segment. All right. When I look at the mid-segment, I know this is only half as long as the base. So x plus 19 needs to be doubled in order to make it equal to x plus 29. All right. So 2x plus 38 is equal to x plus 29. Subtract 38 from both sides, and then subtract x from both sides. I get x is equal to negative 9. I guess x can be negative 9. Is that right? Let's see, negative 9. So if I put a negative 9 here, negative 9 plus 19, yep, that'd be 10. What's negative 9 plus 29? Yep, that'd be 20. Yep, 10 and 20 work, so it is a negative answer. At this time, I'm talking about the angles. How do I know? Because I see the little degree symbol. So that angle is equal to that angle. Those are actually corresponding angles because this line turns out to be parallel to this line. That's a part of a mid-segment, the things we learned about mid-segment. So the angles are equal. So the corresponding angles, they're equal to each other. So 2x angle minus 27 equals x plus 15 angle. So subtract x, add 27. All right, I'm getting x is equal to 42. All right. And the last one, if the mid-segment, if 22 is half of 44, and it is, then this is in the middle. And then way I can prove that that side and that side should be the same. So the 2x minus 9 side should be equal to the x plus 7 side. So when you add 9 and subtract x, I get x is equal to 16. All right. That was 42. I believe that is the last one. And we are completed.